Hello everyone, my name is Xingyu Zhao. You can simply call me Xingyu if that's easier for you to pronounce my name or to remember me. I'm currently a postdoc at the Smart System Group Engineering School, Heriot-Watt University. This is a very quick presentation about my research in this group. I think my research can be summarized by three keywords: verification, assurance, and very recently I started to look into explainable AI. I think I try to contribute in terms of not only improving some fundamental and theoretical aspects of those techniques, but also I try to explore some possible novel applications of them. For verification, basically what I do is probabilistic model checking. I'm an active promoter of runtime probabilistic model checking. And one of the fundamental problems of any types of runtime verification is about how to accurately update the system models at the runtime when you collect new data from the operation. And I think the answers to this question is about, first, how to do robust online estimation of those transition probabilities. And second is about how to do change point detection for those transition probabilities when there is some sudden changes of them. And our solution is to use a set of advanced Bayesian estimators. First, we classify different types of transition probabilities, some of them representing regular in-ones like sensor readings, and some of them are representing very rare in-ones like catastrophic failures. And we built bespoke Bayesian estimators for them, and they can provide us bounded estimates of the probabilities. And they have the ability to detect change point by monitoring the interval width of the bounds. Then we can do interval probabilistic model checking to verify some quantitative properties. To evaluate our techniques, we also explore possible applications like drone inspection missions on the very big wind farms, and we also look into missions like underwater vehicles inspecting and cleaning some undersea chains. In terms of publications, we published at some top tiers conference like AAAI, ASE, and SEFM. For assurance, in my opinion, it's all about how to build up confidence in some high-level claims in safety and reliability. We can do this either in a qualitative way or some quantitative ways. For the former, we normally build safety assurance arguments. We basically reuse or modify some existing argument patterns or blocks for novel AI and machine learning applications, so that we can organize some individually verified low-level properties to support some high-level claims in a structured way. Also, we can do the assurance in some quantitative ways, in which we build rigorous and conservative statistical inference models to update the assurance confidence in a Bayesian manner when seeing some statistical testing evidence. In particular, our approach has the unique advantages of being able to model partial or vague priors, and those prior knowledge can be elicited from different types of verification and validation evidence. In terms of outputs, we also have some top tier publications at safety and reliability conference like SafeComp, ESRI, and also some journal papers as well, like reliability engineering and system safety and information and software technology. You can find all these papers on our group website. For explainable AI, very recently we started to look into a new technique called BayLIME. It is a Bayesian modification of LIME, which is a very popular and successful explainable AI technique. And what we do is to replace the frequentist local surrogate model with Bayesian linear regressors. By doing that, we can embed some prior knowledge into the explanation. And from both analytical studies and empirical experiments, it shows that BayLIME can improve first the consistency in repeated explanations of a single prediction, and also it can help with the robustness to kernel settings when you tune the LIME technique, and also it can benefit the efficiency because BayLIME requires less perturbed samples in the training of the local surrogate models. And we believe BayLIME have some very novel applications, like explaining videos, because in this situation, the knowledge obtained from the explanation of the last frame can be used by the explanation of the next frame. And for this work, we have submitted to an AI conference, and hopefully we will get it published in the very near future. In summary, I'm a very faithful Bayesian. I'd like to seek Bayesian solutions in my research for some real-world problem of safety and reliability. And I believe our research on verification and assurance can be applied in many different levels, like autonomous mission level, in which you need to consider both the systems and the environments. And also at the integrated system level, you need to consider the hardware and software architecture. In the future, we will look into more at the black box AI and machine learning component level. And also, personally, I'm quite interested in what happens inside the AI and the machine learning component. That's the so-called white box level, like the informations in the layers of a deep neural networks. Okay, if you are interested in any of my research, you can find the papers on my website, or you can simply drop me an email here. Thank you for watching.